Hi everyone. So myself or Punita Gauri working as an assistant professor in Erode Engineering College in the Department of Computer Science and Engineering. Today we are going to see about cryptography and network security subjects. In that we are going to see what are the basics things which we have to know before getting into the CNS. So that is introduction to the cryptography. So what does a cryptography means? Here we are having several authors to define cryptography in various terms. So cryptography is the science of using mathematics to encrypt and decrypt data. Cryptography is the art and science of keeping messages secure. The art and science of concealing the messages to introduce the secrecy in information security is recognized as the cryptography. So basically cryptography is a subject which we are going to study uh, by which we are going to study to encrypt and decrypt our data, which means that we are going to ensure that uh, messages which we are sending over to the network will have to reach the destination without any alterations, and no one have to open the messages like that. So we are going to protect our data. So this is the basic behind the cryptography. What are the terminologies which we are going to use means plain text and ciphertext and encryption and decryption. So look at this diagram. So this is the plain text, which means that the original messages which were created by the source is called as a plain text. And in order to transfer these messages over the network, so before revealing the message to the network, what we are going to do means we are going to convert into coded hex text. In technically we will call this as a ciphertext, which means that we are going to convert these messages into some other form so that any attacker or intruder cannot open the messages. If it opens also, they don't understand what is given in the message. Okay, so for that, the process of converting the plain text into a ciphertext, we will use some kind of methods, algorithms. We will call this thing as a encryption process. So the process of converting a plain text into a ciphertext is called as an encryption. So after converting a plain text into a ciphertext, we will send over to the network. This ciphertext is transferred over to the network. So at the receiver side, the same thing, the ciphertext will be received by the receiver. He have to convert into a plain text. For that, he have to use some methods and calculations. That process is called as a decryption. Okay, so after this applying the decryption process, he can convert the ciphertext into a plain text, and he can open and read the messages as well. So this is the overall process behind the cryptography. So what are the components behind a basic crypto system means plain text, ciphertext, encryption algorithm, decryption algorithm, encryption key and decryption key. So as usual, plain text is the original message. It was created by the source, and before sending over the network, the plain text is converted into a ciphertext. For that, we are going to apply some algorithms. That algorithms is called as an encryption algorithms. So in order to apply these kind of algorithms, we need some key to process the algorithm. So that key is called as an encryption key. At the same time, so at the receiver side, we are going to receive the ciphertext, and the receiver have to convert the ciphertext into a plain text. For that, he have to use some decryption algorithms. So the decryption algorithms, we will use some kind of key. That key is called as a decryption key. So these are all the basic components in the basic cryptosystems. So sometimes we will call these keys as a asymmetric secret key like that, which means that both the encryption and decryption algorithms using the same keys, we will call it as a symmetric key. In some kind of algorithms, encryption and decryption keys will use the different kinds of keys called private key and public key. If it is different, both the encryption and decryption algorithms uses the different keys means we will call those algorithms is an asymmetric cryptographic algorithm. So symmetric means we are going to use same key for both encryption and decryption. Asymmetric means we are going to use different keys for encryption and decryption. Okay. So by this concept, we can divide the algorithms, symmetric key algorithms and asymmetric key algorithms. So what is a CIA triad means? So we have to, if we are running an any organization, we have to ensure these three things have to be provided in our organization. So first is a C for confidentiality, I for integrity, and A for availability. So in order to protect our data, we have to ensure these three terms. So what is the confidentiality means? Only authorized individuals or systems can view the sensitive or classified information. So the data being sent over the network should not be accessed by any unauthorized individuals. So we need to protect the secrecy of a message. I'm going to send a message to the receiver, that message should be only read by the destination or receiver. So no one have to open that message, no one have to reveal the message. So we have to ensure this thing in our network. So that is called as a confidentiality, which means that maintaining a privacy, maintaining a secrecy in our network system. So this is a basic thing we have to give ensure in our network system. So in order to give the confidentiality, in order to ensure the confidentiality, what we are going to use means we are going to apply this encryption and decryption algorithm. So hello allies is a original message that before sending over to the network the message, so we have to encrypt the data original message, and we have to produce the ciphertext. This ciphertext is sent over to the network. So at the receiver side, what we have to do is the receiver receives the ciphertext, how to decrypt the algorithm, and the original message was converted, and the allies can read the message. Okay. So in order to ensure that, what we have to do means we have to maintain a secret key between the sender and receiver. By using that secret key, sender can encrypt the algorithm. By using the same secret key, the receiver can decrypt the algorithm. So by this way, so without the secret key, no one can decrypt the message. So no one can open the message. By this way, we can ensure the confidentiality in our network system. So here we have to maintain two things. One is the encryption and decryption algorithm, what we are going to use, and what is the methods behind the encryption and decryption algorithms, and also the key which we are going to use in the encryption and decryption algorithms. So these are all the things we have to know about confidentiality. So the examples of confidentiality algorithms, encryption algorithms is advanced encryption standard and data encryption standard. So DES is the first method which was introduced, and in order to improve the security and more security, we go for an AES. And another one method called virtual private network. So it is a VPN tunnel. So no one can enter into the only the authorized users can enter the tunnel and open the messages. So and these are all the confidentiality algorithms. So next one is an integrity. So we have to make sure that no one have been modified the our messages. So some intruder may open the message and modify the message content. So if it does, then the integrity is not ensured in the network. So corruption of data is a failure to maintain the data integrity. So what are the algorithms which we that we provide integrity means we are going to use some hash algorithms. uh, so what is a cryptographic algorithm? So these are all the algorithms which we are using in the hash techniques. So what is a hash means? So we are going to encrypt the message by using some value. So that what will the hash algorithm will do means will its hash algorithm takes the input as a very large amount of data, and it will produce very small of data. So what is the uh, basic behind hash algorithms means every original message we will have a different hash value. So for example, if I'm having a message A and message B means, if I apply algorithm means hash algorithm means, I will get the two different hash values. So the hash values will not be unique for two different messages. So that is the thing behind the hash algorithm. So what will happen in the network means we are going to encrypt the message, and we are going to do the we are going to apply the hash algorithms with the original message. We are going to send the hash value also to the receiver. So at the receiver side, he will apply the same hash algorithm with the original message which we have received, and it will produce the hash value. If both the hash values same means it will accept the message. We can say that the integrity is ensured. If the hash value is different means we should know that somewhere some intruder have been changed the messages. So by this way we can ensure the integrity. So the next one is an availability. So what is availability means? So the for all the eligible users, the network and the services should be available at any time. So how can we how the intruder will crash the availability means it will produce some bogus messages, bogus request. It will affect the denial of service. What is the denial of service means? By we are going to generate some unwanted request to the server, so that the server will hang up and it could not produce the services which we are asked by the client. So this is the attack to that will break the availability of the systems, and also the attacker will create some viruses. So what is a zombie means? Zombie is a type of virus, so that will affect the entire network system. So we need to protect our system by the network will not be affected by any kind of virus, and it will also should handle the denial of service messages. Okay, so the attacks are denial of service, or sometimes we will call as a distributed denial of service. Okay, so this is the network model, and so this is the overall scene behind the network security. So this is the original message which we are created, and we are going to send the secret information by using this. This is the encryption algorithm. By using this, we are going to convert the message into a secure message. So this secure message is sent over to the network, and at the receiver side the secure message was received. By using the same security related information, we are going to convert the secure message is a original message. So all these things, so the sender and the recipient and the network, so all these have been approved by the third party auditor. So trusted third party. So all the information, the security algorithm, security keys, so everything will be maintained by the trusted third party. So this is the overall network model. And next one is a very important thing, OSI security architecture. So IEEE recommendation X.800 security architecture for OSI defines such a systematic approach. So in this OSI security architecture, we are going to focus on three things. So what is a security attack? So what are all the mechanisms and what are all the services provided by the OSI? So first we will look at the security attacks. So what is an attack means? Any action that compromises the security of the information owned by an organization, which means so we have to ensure the confidentiality, integrity, availability, right? So so any action that affects the system's confidentiality, that affects the integrity of the message, that affects the availability of the server means that action is called as a security attack. So what is a security mechanism? So a process or a device that is designed to detect and prevent or recover from the security attack. So in case the security attack has been happened means we have to know that where that happened. So who is the intruder, who is the attacker, and in future we have to prevent such kind of security attack. So all those things can be done by the security mechanisms. And what a security service means? A processing or communication service that enhances the security of data processing system and the information transfers of an organization, which means that what are all the security services which we are provided over the network is called as a security services. So we will see each and security attack, security mechanism, security service in a detailed way. So what is a security attack means? So we can classify the security attack into two types: passive attack and active attack. So what is a passive attack means? So it just wants to learn, or it just wants to open the message. It just wants to open the content, reveal the content of the original message is called as a passive attack. Active attack means the attacker will modify the message, will alter the messages which we have sent over to the network, which means that so passive attack is something in order to break the confidentiality. It just break the confidentiality. In the same way, active attack will break the confidentiality and as well as the integrity of the message. What is integrity? We need to maintain the originality of the message. If the originality is not maintained, then we say that the integrity is not given by the network system, right? So passive attackers, what will do means just they wants to know what is the messages sent over the network. So that is a passive attack. Active attack means they wants to learn the message and they wants to modify the message. This is an active attack. Okay. So in passive attack, it is the nature of eavesdropping or monitoring or transmissions. Eavesdropping means we are going to overhear what is happening between the what is the message conversation happening between the sender and receivers. So the goal of the passive attack is just to know, is just to wants to obtain the information, just to wants to reveal the information. Okay. So two types of passive attacks are there. First one is a release of message contents, and another one is a traffic analysis. So what is the release of message contents? Which just they want to open the message. And what is the traffic analysis? This is a very interesting one. So what is the traffic analysis means? So the intruder will sit to over to the network, and he wants to know what kind of messages is transferring between the sender and receiver. So at what time they are communicating, and what are all the secret information behind the conversation. So these are all the things they want to know. So just they will sit and analyze who are all communicating with who and all. So who is the source, who is the destination, at what time they are coming, what kind of messages they are transferring. So it is a normal text message or images or videos, or some kind of money transformation is happening between the sender and receivers. So they want to analyze what kind of messages are transferred between sender and receiver. So in order to do the active attack, in order to uh, do the active attack, in order to alter the messages, so the first the attacker will go through this type of passive attacks, and they will convert into an active attack one. Okay. So these are all the release of message contents. So the Bob is creating a original message, and Alice is the receiver. So in between the Bob and Alice, the intruder will read the contents of the messages that will transfer from Bob and Alice. So what is traffic analysis means? They observe the pattern of messages from Bob to Alice. It can be a message text, if it is a message text, or they are transferring images, or they are transferring some videos, they are transferring some money transformation. So what is happening between Bob and Alice? Just they want to analyze this. This kind of attack is called as a traffic analysis. So next one is an active attack. So active attack is a severe one. So they will involve some modification of the data stream or the creation of false stream. So that they will involve the they will modify the messages, or they will send the message as like a original user. So the attacker is going to send a message to the receiver, but the receiver will think that yes, this message was sent from the original user. So these kind of attacks is called as an active attack. So there are four categories in active attack: masquerading, replay, modification of messages, and denial of service. So what is masquerade? So masquerade means, so the message from dot that appears to be from Bob. So in this case, the original sender is not a Bob. So as like Bob sent the message, thus attacker will send the messages to the allies. So what will allies think? That yes, the message was sent from the Bob. Okay, the one pretend to act as a original user. Here the attacker will act as a Bob and send the message to allies. So this kind of attack is called as a masquerading. One pretend to act as the original user is called as a masquerading attack. Next one is a replay attack. Actually, the message transferring is happening. The message was created by the sender, created by the Bob, but the message was stealed by the attacker, and he will do some modification in the message, and that modified message is sent to the allies. So the original message is altered, and it is sent to the allies. So this kind of attack is capturing the message and alter some messages, later it is sent to the allies. So this type of attack is called as a replay attack. And modification of messages, as we said, the sender will modify the message, is called as a modification of messages. The attacker will modify the message. A denial of service. Okay, so denial of service is happen only in the server. Okay, so the attacker will hack the server, will produce some kind of virus or unwanted bogus request to the server, so that the server cannot provide the service to the original users. Okay, so this kind of attack is called as a denial of service, which means that we are going to stop the server to be serviced by the client. And next we will get into a security service. So what is a security service? Is a service that is provided by a protocol layer of communicating open systems, and that ensures the adequate security of the system or of the data transfers. We have to ensure that yes, we are providing a security architecture, we are maintaining a security architecture for transferring our data. Okay, so these are all the services in security. First one is an authentication, access control, data confidentiality, data integrity, and finally non-repudiation. So what is the authentication means? So we have to ensure that communicating entity is the one that it claims to be, which means that original user is only sending message, original receiver is only receiving a message. So we have to ensure that says yes, I am the eligible user to access the message. So before accessing the message, we have to um, prove that yes, I am a original user, I am a pretend user to use this one. For this, what we can provide means we can provide a login ID and password, so that the eligible user only can send a message and receive the message. So there are two types of authentication: peer entity authentication and data origin authentication. So next one is what access control. Access control means we have to prevent that unauthorized access of the system. So we have to provide the access control. Only the legitimate user can access the system is a access control. So the next one is the data confidentiality. So to protect, this is the process of protecting our data from unauthorized disclosure. Okay, so no one other than the original user, no one have to open the message, no one have to read the message. So in this four types are there. First one is the connection confidentiality, connectionless confidentiality, selective field confidentiality, and traffic flow confidentiality. Next one is the data integrity. So this is the assurance that data received are exactly as sent by the authorized entities. That is, no one have modified our messages, no one have entered some data, no one have deleted our messages. Like that we have to ensure. So in this also we are having 5 different types: connection integrity with recovery, connection integrity without recovery, and selective field in connection integrity, connectionless integrity, selective field connectionless integrity. So next one is the non-repudiation, the final thing. So it provides the protection at time denial by one of the entities involved in a communication of having participated in all or part of the communication. Non-repudiation means the original user, the original sender may deny that no, that messages was actually not sent by me. and or sometimes the receiver may send that no, I have not any received such kind of message, but the actual thing is the original user have sent the message and the original receiver have received the message. So but after some time the original sender or receiver may turned as an attacker. The sender may deny that no, I have not sent such messages. That the receiver may deny that no, I have not received such kind of messages like that. So in order to provide this non-repudiation service, what we are going to do means we are going to agree, we are going to do a agreement with the third party. So all the messages which was sent by the sender and all the messages which was received by the receiver, a copy of all these conversation messages will be maintained by the third party. If any sender may deny means we can prove with the third party, yes, no, I am having a copy of that, yes, this messages was sent by you. And at the same thing, a receiver also may, if receiver denied no, no, I have not received such kind of messages means the third party will prove that yes, this messages was received by you. We are having a proof like that. So the non-repetition service can be done with the help of the third party. Okay, so there are two types: non-repetition origin and non-repetition at destination. So these are the security services. So the finally we came into the security mechanisms. So in order to provide all the security services and in order to know the security attacks, in order to prevent the security attacks, we are using these type of security mechanisms: encipherment, digital signature, access control, data integrity, authentication exchange, traffic padding, routing control, notarization, pervasive security mechanisms, trusted functionality, security label, event detection, security audit trial, security recovery. So these are all the various kind of mechanisms. Each these mechanism having some kind of methodology to adapt the security services. Okay, thank you.